Hello viewers, welcome back to my channel Shraddha's Physics. In this part we will see the interaction of the radiation with the matter, that is we will discuss here what is stimulated absorption, spontaneous emission and the stimulated emission. So let us start our topic, that is the interaction of the radiation with the matter. So first of all we will discuss about the stimulated absorption. So let us consider there are two energy level, that is suppose this is your E1 energy, this is E2 energy level, that is the higher one, and the lower energy level, this is suppose E1 energy state. Okay, this energy level is also known as your ground state and this is your excited state. And also we know the energy difference between this E2 and E1 is h nu, that is we can write E2 minus E1, that is equal to h nu, that is the energy difference between the two energy level. So suppose the photon energy E2 minus E1 equal to h nu, it interacts with an atom that is present in the ground state. So suppose for example the atom is present, suppose here, that is at the ground state, and we all know that is in the E1 state, that is the ground state, it has the lowest energy. But in the excited state, that is if an atom it will want to jump to the excited state, then it need the amount of energy that is h nu. So that is if this atom it will get the h nu amount of energy, then it will try to go to the state E2. So when this atom get excited, that is the atom present in the ground state, when it will absorb the energy, that is h nu amount of energy, when this atom will absorb, then it will go to the excited state, that is your E2 state. And this particular process is called the stimulated absorption. Stimulation means supplying additional amount of energy. Okay, so this atom gets stimulated by supplying or by absorbing this h nu amount of energy, so that it will get excited and it will go to the excited state E2, and the process is called as the stimulated absorption. Now in this diagram you can see, suppose this one is your atom in the ground state. After getting the energy, that is the energy difference between the two states, since it is h nu, so by getting this amount of energy h nu, it will go to the excited state. So this is the atom present. After getting the energy h nu, it will reach to the state, that is your E2, and this process is called the stimulated absorption. So here basically you can see that the stimulated absorption rate, it will be directly proportional to the number of atoms present in the ground state. That is if there are n1 number of particles are present, so by getting every atom, that is h nu amount of energy, when they will absorb this amount of energy, then all the atoms that is present in the excited in the ground state, they will go to the excited state. Okay, so basically we can say that this stimulated absorption rate, it will depend on the number of atoms present in the ground state, that is n1. So this is proportional to the n1, and also it depends on, that is it is also proportional to the density of the photons, that is u of nu. So the stimulated absorption rate, it depends on the number of particles present in the ground state, that is n1, and the density of the photon, that is u of nu. So by considering the proportionality constant, that is B12, that is your for the stimulated absorption. So this is your B12, that is your Einstein coefficient. I will discuss it later in the next class. So this is your B12 into N1 U nu. This is your N1 into U nu, and this B12 is the stimulated absorption constant. Okay. Now we will discuss on the spontaneous emission. So this spontaneous emission, it was postulated by Bohr. So now again this one is your suppose E1 energy state, and again this one is your E2 state, that is your excited state. So this E1 and E2 be the energies of the ground and excited states of an atom, and again the photon of energy E2 minus E1 equal to h nu, it interacts with an atom present in the ground state. So in case of the stimulated absorption, we know since the atom is present in the ground state, it has the lowest amount of energy. So by absorbing the amount of energy, that is suppose h nu, it will goes to the excited state. So now this atom goes to this state, that is your excited state. Now this atom is present. Since here in the excited state, the lifetime of the atom is just about for the 10 power minus 8 second, as we have discussed in the previous classes, that is the lifetime of this atom is 10 power minus 8 second. So this atom cannot stay here for the longer time. Now it will spontaneously emitted, or we can say that it will now de-excited and come back to the ground state. So here you can see, so this, if the photon of energy h nu it interacts with an atom present in the ground state, the atom gets excitation from the ground state E1 to the excited state, that is E2. So the excited atom doesn't stay in a long time in the excited state. It gets de-excited after its lifetime by emitting a photon of energy h nu. So when it will come back to the ground state again, it will emit the amount of energy, that is your h nu. So simply, so to excite an atom that is present in the ground state, it need the amount of energy, that is h nu, to go to the excited state, that is E2. And after de-excitation, when this atom present in the E2 state, when it will jump to the ground state, then also it will emit the radiation of energy, that is h nu. So to go from the E1 to E2, it will need energy h nu, and when it will jump from E2 state to E1, that is to the ground state, so it will radiate the amount of energy, that is h. So this process in which the spontaneously the atom come back to the ground state by emitting the amount of energy, that is h nu, that is called spontaneous emission. So during spontaneous emission, you don't need any additional amount of energy, since basically the lifetime of the atom in the excited state is very less, that is 10 power minus 8 second. So after its lifetime, it will get de-excited and come back to the ground state. Okay. So this phenomenon is called the spontaneous emission. So now you can see here. So atom is already present in the excited state here. Since it cannot stay for the larger time, so it will come back to its ground state by emitting the amount of energy, that is h nu. So here the spontaneous emission rate, it will be directly proportional to the number of atoms in the excited state. So the more the number of atoms present in the excited state, so the more number of atom will come back to the ground state, or it will emit more amount of energy, that is h nu. So because when single atom it will reach at the ground state, it will emit h nu amount of energy. Then for another atom, when it will come back, then it will again release h nu amount of energy, and so on. Okay. So here we can say that the spontaneous emission rate, it will proportional to the number of atoms present in the excited state, that is N2. Okay. So basically here N1 and N2, this is because of the E2 state. So simply here I am saying this is the number of atoms will be N2, and for E1 we have considering, that is suppose the number of atoms are N1. Okay. That is in the, as per the previous statement, that is the, in case of the stimulated absorption, we have considered the number of atoms present in the E1 state is N1. Simply this is your 1 state, that is the ground state, and this is for the 2 state. So simply we are denoting it as N2. Okay. Now we will discuss on stimulated emission. This stimulated emission, it was postulated by Einstein, whereas the spontaneous emission was postulated by Bohr. Now again, these are suppose E1 state, and this is suppose E2 state, again the excited state, and this is your ground state. Let E1 and E2 be the energy of the ground and excited state of an atom. Suppose if a photon of energy h nu interacts with an atom present in the ground state, the atom gets excited from the ground state E1 to the excited state E2. So now I will tell you that after I will show you what is being written here. So suppose the atom is present in the ground state here. Okay. So by absorbing the amount of energy, that is h nu, this is for single atom I am considering here. So when this atom present in the ground state, it will absorb the energy h nu, then it will go to the excited state. This one is your excited state. Okay. Just a minute. Okay. So the atom now present at this point. Now if some additional amount of energy, that is h nu, is given at this point, that is the atom where it is in the excited state, if I will supply some amount of energy, that is h nu, then it will get de-excited that is it will come back to its ground state by emitting two energy, that is one is your h nu and another one is your h nu. That will we can say that here these two photons, that is h nu and h nu here, they will be in the same phase, or we can say that it will follow coherence. Because when in case of the spontaneous emission, okay, the atom is already present in the excited state. Just in the previous case, the atom is already present in the excited state. Since here the lifetime is very less, that is 10 power minus 8 second, so spontaneously it will get de-excited and it will go to the, or it will come back to the ground state by emitting the amount of energy h nu. This is the real case. But since here we are giving the additional amount of energy, that is h nu, so here we will get the two energies, that is one for your spontaneous emission you can say, or another the additional amount of energy that we have given h nu, that is also here radiated. So this phenomenon is called as the stimulated emission. Now here one question arises, that the atom present in the ground state, just listen carefully, the atom that is present in the ground state, after getting or after absorbing the amount of energy h nu, it will go to the higher state, that is E2. But here the atom that is present in the excited state, by absorbing the amount of energy h nu, it will not go to the higher excited state, that is suppose this is your excited state E3. Then why it is not again excited and not reach to the E3 state, rather it will fall back to the ground state? This is just because this amount of energy h nu, that is not sufficient here to reach at the energy level, that is your E3. Because here in this E2 energy state, that is your excited state, here also the lifetime is very short, that is for your 10 power minus 8 second. So here the atom will live for a very short time, so it will try to spontaneously emit it, and also when it get amount of energy h nu, it will also radiate that amount of energy. Okay, simply we can say that this amount of energy h nu that we are giving to the excited state, that is not sufficient to reach at the excited state, that is your E3. So here you can see that let a photon of energy h nu, it interacts with the excited atom with their lifetime, so the atom gets de-excitation to the ground state by emitting another photon. So these photons have the same phase and it follows the coherence. This phenomenon is called the stimulated emission. So here you can see that the atom is already in the excited state here. So when you give some additional amount of energy, that is h nu, it will get de-excited and releases the amount of, it will release the amount of energy h nu, as well as it will release another h nu because of the photon of energy, that is h nu here we have given additional. Okay, so here the stimulated emission rate, we can say it is directly proportional to the number of atoms in the excited state, that is your n to the number of atoms present in the excited state, and also it will depend on the energy density of the photon, that is your U of nu. Why the energy density? Because in case of the stimulated, whether it is stimulated absorption or in case of the stimulated emission, in both the case it will depend on the density of the photon, because the amount of photon you are supplying, that is to stimulate an atom, so that is because depends on the stimulation rate, that is in case of the stimulated emission rate, it depends on the energy density of the photon, as well as in case of the stimulated absorption also it will depend on the energy density of the photon. But in case of the spontaneous emission, it will not depend on the energy density. Why? Because in the spontaneous case we are not giving any amount of energy to the atom. Okay, now we will see the difference between the spontaneous emission and the stimulated emission. The spontaneous emission, it was postulated by Bohr, whereas the stimulated emission, it was postulated by Einstein. The second one is the additional photons are not required in spontaneous emission. So in case of the spontaneous emission, we are not giving any additional photons to excite the atom, but here in case of the stimulated emission, we need the additional photons to stimulate the atom. Okay. Now the next one is one photon is emitted in case of the spontaneous emission, but here in the stimulated emission the two photons are emitted. The next point is the emitted radiation is not monochromatic in nature in case of the spontaneous emission. But in case of the stimulated emission, the emitted radiation is monochromatic in nature. The next point is, in case of the spontaneous emission, the emitted radiation is incoherent. But in case of the stimulated emission, the emitted radiation is coherent in nature. Okay. The emitted radiation in case of the spontaneous emission is less intense, whereas the emitted radiation is highly intense in case of the stimulated emission. Okay. The last point is, the emitted radiation, it have less directionality. That is, the light from the sodium or mercury lamp, this is the example of the spontaneous emission. And in case of the stimulated emission, the emitted radiation have highly directionality property. So here the example is the light from the laser source. So these are the basic difference between the spontaneous emission and the stimulated emission. So the conclusion that we get is, in case of the spontaneous, let me write first. In case of the stimulated absorption, that is the stimulated absorption rate, we can say it is directly proportional to the number of particles present in the ground state, because in case of the absorption, you will give the amount of energy to the atom present in the E1 state, that is, you will give h nu amount of energy to the atom present in the E1 state. Suppose here n1 number of atoms is present and this one is your E2 state. So after gaining this amount of energy h nu, it will goes to the highest state. Okay. So here in case of the stimulated absorption, it is directly proportional to the number of particles available in the ground state, as well as it is directly proportional to the density of the photon, that is here I can say U of nu. Okay. Now in case of the spontaneous emission, now if I write here, in case of the spontaneous emission, the atom already present in the spontaneous emission, the atom already present in the excited state, this is your E2 is the excited state and E1 is the ground state. So the atom already present in the excited state, it has the lifetime 10 power minus 8 seconds. So it cannot stay for the more time or for a longer time in this state. So it will spontaneously come to the E1 state by radiating the amount of energy, that is your h. Okay. So here we can say that this spontaneous emission is directly proportional to the number of atoms. Suppose here N2 are the number of atoms present in this state. So here it is directly proportional to the N2. Since here we are not giving any additional amount of energy to it, so simply it will not depend on the energy density of the photon. Okay. But here, while it will jump from the E2 state to the E1 state, so in this time it will radiate an amount of energy, that is h nu, or this is the photon of energy it will radiate, that is your h nu. Now finally we studied, that is for your stimulated emission. In case of stimulated emission, the atom present in the excited state, that is suppose your E2 is the excited state, the atom present in this excited state will supply some additional amount of energy, that is your h nu, so that this atom present in the excited state, it will come back to the ground state by releasing the amount of energy, or by releasing two photons, that is h nu and again the h nu, and this is called the stimulated emission. And here this stimulated emission is directly proportional to, you can say here the number of particles present in the E2 state, that is your excited state is suppose N2. So it will depend on the number of atoms present in the excited state, and also it directly proportional to the, here we are giving the additional amount of energy, that is h nu, so that it is proportional to the density of the photon, that is your energy density of the photon, that is U of nu. So this is all about stimulated absorption, spontaneous emission and stimulated emission. So in case of the stimulation, that is your stimulated, whether it is stimulated absorption or it may be the stimulated emission, in both the case you can see it depends on the U of nu, but in case of the spontaneous emission, it will not depend on the energy density of the photon. Okay. So this is all for today. If you have any doubt, can ask me in the comment section. Thank you all.